Hello everyone, this is Anurag and now we are solving Leetcode 131, that is Palindrome partition. This is a very good question of backtracking. So let's see what the problem statement is. So problem statement is we have to return every substring of this string which is palindrome. For example, let's the output will be A A B, similarly A and B. Why this is the output? Because see, A is a substring and it is a palindrome also, so it will go into the answer. A, again this A is also a substring, so and it is also a palindrome. Similarly B is also a substring and a palindrome. A is also a substring and it is also a palindrome, so that is why it is in the answer. And again this B is also a substring, so it is in the answer. So why this B is two times? Because when we are traversing, when we will apply like backtracking logic, it will traverse it two times. That's why it has came into the output two times. Okay, so if it is if the question will be like give only unique substrings, so we can use a hash map and then hash map or set and then convert it into the vector. It will also return as the unique combinations. Okay. So let us see how we'll solve this question. So to solve this question, first we have to take the substrings. Okay, so how we can take the substring will this will be a substring, then this will be a substring, this will also be a substring. So how can we do? So first take like there can be multiple options na? We can take a or only a or aa or aab for a substring. So from this logic we can identify that this is a backtracking question or recursive question. Okay, so let's start to make recursive tree, because after making recursive tree we'll easily identify uh, the code. We can easily write the code. Okay, so let me take another example which is a little bit a big example. See AABC. So for this I am taking this first A and I will check if this is a palindrome. Yes, this is a palindrome, so okay, I'll add it in the answer and then apply my backtracking logic on this. Similarly, I will take AA and if this is a palindrome, so I will add it in the answer and I'll apply my backtracking logic on BC. Similarly, I'll take AAB and C. But to constrain, to reduce the time complexity, what we can do is we can check if this is a palindrome or not. So if this is if this is not the palindrome, then we do not have to go further. We do not have to check it for the rest of the substring, because if this isn't a palindrome, if this is not a palindrome, how can how can this be the palindrome AABC? How if AAB is not even the palindrome, how can AABC will be the palindrome? So okay, so for that reasons we'll see, since this is not palindrome, we'll not go this side. Similarly AABC will not go this side because these two are not palindrome. For this again we'll apply this logic. We'll take A. If A is palindrome, then we'll go to BC. Similarly B, if B is palindrome, we'll go to C. For from this part of the tree we'll get the answer A, B and C, all the single elements. Now similarly, if AA is the palindrome, we'll go to BC. We'll take BC. If BC is palindrome, no, BC is not the palindrome, so we'll save only this. And if AAB is the palindrome, AAB is not the palindrome, so we'll not take those trees. Similarly, this will happen like B and C. And again, if B is palindrome, then we'll try for C. So C is also palindrome, so we'll again get 2 BC. B and C, we'll again get B and C. And for that reason also in the output of AAB they were 2 times B, and for the same reason we are having 2 B's and 2 C's. Yeah. So what will be the pseudo code? How we'll write? So first ARR of size if our index, like we'll pass the index, if the index like starting on this index will go till here. So if index is equals to size, then what we'll do, we'll add it to the answer, like result dot push answer and just return. Okay, if it is not, then what you have to do, like for int I equals to index, from index move on to the last index, like from index move this size and move to size. And what we'll do, we'll first take an string, let's say empty string p, then we'll add p is equals to p plus arr of I. A, we are taking A. Okay, so if this p is palindrome, we have to write that code also. If p is palindrome, then what we have to do, we have to if p is palindrome, we can add it to the, if p is palindrome, then add it to the answer, you know, answer dot push, add it to the answer, and if p is palindrome, add it to the answer. And what next we can do, then form a loop, like, and use this for the next values, you know. If like a is palindrome, so we added it in the answer, and after adding it to the answer, what we have to do, solve it for the next iteration. That, but there will be I plus 1 or index plus 1. There will be I plus 1, and I'll explain you why I plus 1. See, because a b c, we are given this index, we are moving in this way. Okay, so let's say we are on this, like we are on this, so we have to make loop on this. So for this, what will be the index is on a, and I is on here, I is here. So this is what it is. So for this part, what we have to do, we have to do I plus 1, because I is here and index is here. If I'll do index plus 1, then it will take a b c as the substring, which we don't want. We want bc. So for that reason, I am putting I plus 1. Similarly, if again I want to show you an answer, if I is 0 and index is here, so we want this index. But if we put index plus 1, this time it is index plus 1 and I plus 1 are same, so that's why no issue will happen. But if the case is like ABC, index is here, I is here, so we want only C. But if we'll give index plus 1, all this will come. So for that reason, we are doing I plus 1. So I plus 1, and similarly I plus 1, and pass rest of your parameters. And for backtracking logic, answer dot pop back, like after going this, pop back, going this, pop back, doing this, pop back, and take 2. So this is the pseudo code, and let's try to run it on PC if it works. Okay, let me explain you palindrome logic also, no? Because we have to write the code for palindrome also. Is palindrome, we are checking palindrome, so if it is palindrome or not. So for palindrome, any string to be palindrome, use 2 pointers approach, left and right. We'll use left and right pointers, and if these two are equal, we'll move forward. If these two are equal, we'll move forward. And any point these two are not equal, we'll return that no palindrome, they are not palindrome. Because for a b c palindrome, for just a second, for let's say palindrome, madam is a palindrome, so madam is a palindrome. These two should be equal, then we'll go to the here, these two should be equal, and again when they will coincide, they will automatically be equal. When start is less than start will become greater than equal, we'll exit the loop. So this is the very basic code for palindrome. I hope you guys know it. In case you don't, I told you. Okay, So this is the question, palindrome partitioning. Let's solve this. So what we'll need, we'll first make a vector. We have to return a vector of vector strings. Okay, we'll pass vector of vector string answer. Let's call it result, because we'll need two string. And again we'll make a vector int, not int, sorry, string answer. Okay, okay, where is the cursor? Answer. Okay, now what we have to do, just we'll have to write the solve function and palindrome function. So let's call it solve function. We'll give a small s, a small s. Solve function will give what? Will give an index. Index will start from 0. We'll give temp, not temp. We'll give you a result and we'll give you answer. These three things we have to give, and obviously string s, with string s we have to give a string s. Okay, and we'll return what result we will return. So let's write solve function. What will be the return type? Nothing. Solve function will just modify it. Okay, so int index vector string will pass by reference result, and vector string answer. Answer, this will also be by reference, and what, string s. So base condition will be if index is equals to size string dot, sorry, s dot size. Then what we have to do, we will add the answer to the result. We'll add answer to the result and we'll return. And if this is not the case, we'll do whatever I discussed. We'll give a loop for I equals to I less than s dot size and I plus plus, and first we will have to take a string, so that initialize empty string, so that we can add the characters in that string. Okay, just a second. Yeah, empty string p equals to p plus s of I. Okay, now if this p is palindrome, we'll write this function palindrome. If palindrome, if this is true, then what we have to do, that answer dot pushback p, and again solve for I plus 1. I have told you why we need I plus 1, and result and answer and string s. Then for backtracking logic, answer dot pop back. I hope this is clear, and let's write is palindrome function, and is palindrome function will be of type bool. Is palindrome, and it will take an string s. this palindrome will take a string s, and int s will be on 0. We'll take the 2 pointers, left pointer on 0, int r pointer will be on string dot, not string, s dot size -1, and while s is less than and equal to, notice l is less than equals to r, what we have to do? If s of l is not equals to s of r, what we have to do? Just return false. It is not a palindrome, and modify l will move forward and r will decrease. And if this loop successfully ends, that means it is a palindrome, so return true. So yeah, this is the code. I hope it should run. Let's check. Something is did you mean string? Okay, there is spelling mistake. string string. Okay, there is again a spelling mistake, typo. Oh, I have put a colon, semicolon. I have to put a comma. Again, let's see. Okay, finally, with some typos, we have done it correctly. Let's submit it. Yeah, it runs. So the only catch was we have to take one character and pass the rest of the string. We took one character and passed the rest of the string for backtracking. Rest of the string will be tracked by backtracking. So yeah, this was the code. Thank you.